Hi everybody, today's lesson is about exponential growth. So the first part of our notes is the exponential growth and decay model. That is a formula we're gonna use to take us through this lesson. In this formula, A is the initial amount, R is the rate, and T is the time. The quantity 1 plus R is called the growth factor, and if the factor is greater than 1, it's exponential growth. In the next video, we'll talk about the latter, which would be exponential decay. So the idea is that we're going to use that original formula to help us solve these problems. So there's a pond stocked with 200 fish, and the Department of Wildlife expects the population to increase at a rate of 5% each year. How many fish will there be in the pond after 5 years? So what I need to do is fill in the information. So 200 is my initial amount, and then I have to use 1 plus. So I didn't say that earlier, but this formula says plus or minus. You have to pick based on whether it's exponential growth or decay. So this says increase, so I'm going to use a plus. And then comes rate, which is 0.05. And then T is 5. So again, I'm just using this formula, substituting an initial amount, rate, and time. And then to solve this, you just need your calculator. So what you need to do, is take out your calculator and you're just going to type this in. It was 200 times 1 plus 0.05 to the 5th power. And I'm realizing now that you're having some trouble seeing that. That should be better. And you press enter, and you get 255.2, about 55.3. So this is approximately 255.3. However, it is impossible to have 0.3 fish. So you would round that down to 255 fish after 5 years. The next piece is to know when that would double. So double would be 400, right, our ending value. So then my initial value stays the same. I've got 1 plus 0.05, but this time it says when. So I'm looking for T. So we use our calculator for this. You need to put the left side in Y1 and the right side in Y2. And you're going to find the intersection. So let's see what that looks like on the calculator. So you're going to go to Y equals, and in Y1 I'm going to type 400 on the left side of my equal sign. And then I've got 200 times 1 plus 0.05 to the x power. Right, we always use x in our calculator for our variable. However, if you go to your graph, you're likely not going to be able to see anything because this 400 here means that our graph, our y values, must be at least 400. So I'm going to change my y max to maybe 450 because it has to be bigger. And then I'm going to go to my graph. So now you can see that horizontal line. I just have to make sure I can see the intersection. So I currently can't see the intersection, so I need it to go further to the right. So I'm going to change my x max to like 35. And you may have to play around with these values in order to find the intersection. So once you can visually see the intersection, you're going to go second calc, number 5, enter, enter, enter. So here I've got 14.2. So T is 14.2. So you're going to have double the amount of fish after 15 full years. And the reason you can't round down here, because if you go down to 14, you're not going to quite have double the amount of fish. So you do have to round up to 15 years. Alrighty, example 2 is very similar. And this is about tuition. So the cost of tuition at a state university was $4,300. During the next 8 years, the tuition rose 4%, and rose would mean increased 4% each year. So let's write a model that gives tuition, y in dollars, and t years after 1990. So the tuition started at $4,300, and then I've got 1 plus because it's rising, and the rate is 0.04 to the t power. So that's the model we can use to make predictions. So what they want us to do is to figure out in what year will the tuition be slightly more than double than it once was. So double would be 8,600. And I've got 1 plus 0.04 to the x power, or t really, but in your calculator you'll put x. So anytime you have a variable in the exponent, you're going to use your calculator to solve it. So what I want you to do is take out your calculator right now, type these into y equals, find a window that works for you, and find where those intersect and answer this question. No, really, I mean it, you have to pause. So you should have gotten t equals 17.6. So then it would double after 18 years, but it's from 1990. So that's in the year 2008. Again, make sure you know how to do this in your calculator. If you want to go see the example before, please do so. So the next piece of information we're going to give you is the compound interest formula. So this compound interest formula will help us make predictions using this information. So A is the end value, P is the principal or initial value, the number N is the number of times it's compounded per year, T is time, and R is rate. So we're going to use this formula to help us figure out how much money we'll have in a bank account based on how often it is compounded. So this says you deposit $2,000 into an account that pays 6% annual interest. Find the balance after 3 years if it is compounded. First, we'll do annually. So annually means one time per year. So I want to know after 3 years what I have. So I'm looking for my end value. So I start with 2,000. I've got 1 plus, and then I got to go with a rate divided by n. So the rate is 0.06. N is 1, and then to the nt power is 1 times 3, because it was 3 years. So what you're going to do is you're going to type that in your calculator. So you got to quit, you're going to go 2,000, 1 plus 0.06 divided by 1, raised to the, make sure you use parentheses, especially if you have an older calculator, 1 times 3 power. Close your parentheses, you get $2,382.03. So let's move on to part B. So this says quarterly. Quarterly means 4 times per year. So nothing really changes except for that n value. I'm still starting with $2,000. I've got a rate of 0.06, but this time I get to divide by 4 and then multiply 4 times 3. So this, again, take a second, plug that in your calculator. You get $2,391.24. Monthly, how many months are in a year? 12. So this is going to be 12 times per year. So again, we're using the exact same formula. My initial value was $2,000. I've got a rate of 6%, but this time I'm compounding 12 times per year. So I've got 0.6 over 12 and 12 times 3. So again, take a second, type that in your calculator. Everybody's typing it in their calculator, so you can make sure you know how to do it. $2,393.36. And then lastly is daily. Daily would be 365 times per year. So I'm starting with $2,000. My rate is 0.06, and this time I'm compounding 365 times per year, right? That's n. Then I've got 365 times 3, right? That n times t up in that exponent. So when you type that in your calculator, you've got 23.94 Okay, so based on the number of times it's compounded, You can make different amounts of money, which is great. We always want to make money on interest. So the last example is another compound interest problem, and it's compounded weekly. So you want $5,000 3 years from now. So what do you think that $5,000 is? Your initial value or your end value? Well, it's your end value because you want it 3 years from now. So you want to know how much should you start initially. So that is P. So 1 plus, I've got 1.5% is 0.015. It's being compounded weekly. There are 52 weeks in a year. And then you've got 52 times 3. So you have P times this value, and you're looking for P. So what you can do is you can type this whole piece into your calculator. And I'm going to do that with you. So that was 1 plus 0.015 divided by 52 raised to 52 times 3, right? 3 years from now. So that's 1.046. So I've got 5,000 equals P times 1.046. But that really goes on forever. And I do not want to round. I do know that I need to divide by that number in order to get P by itself. And what I'm going to do is I'm going to use it in my calculator. I'm going to say 5,000 divided by. And then I want you to go second answer, which is second this negative key. And it's going to pull up that number without having us round anything. And it just makes everything a little bit better. So P is $4,780.12. So that's what you need to start with initially to end up with $5,000 in 3 years. So that's our video on exponential growth. Make sure that you know how to do everything in this video. Feel free to rewind, rewatch, and write down any questions on your note sheet that you have, and we'll see you in class.